Hello and welcome everyone. Thank you for joining us for today's webinar. Today we're going to see the introduction to machine learning and the application in geoscience. Before we begin the session, please allow me to briefly introduce our company, 𝗟𝗶 Oil and Gas Solutions. We offer a wide range of specialized services, including technical reservoir studies, field development planning, reservoir static and dynamic modeling, technical support for academic research, like in PhDs and master degrees, assistance in writing technical papers and publications, mentorship programs, and customized training courses. Today, we are pleased to introduce our STEAM instructor, Mr. 𝗟𝗲𝗿H𝗶𝗴. Mr. Amar is a geoscientist with over 5 years of experience in geology, geophysics, and production operations. He currently serves as a development geologist at General Petroleum Company, supporting reservoir development, geological modeling, and subsurface studies. Mr. Amar is passionate about merging geoscience with digital innovation to enhance field development strategies. Mr. Amar, welcome to 𝗟𝗶 Solutions, and thank you in advance for your presentation.
Okay, thank you for all of you. Okay, hello everyone, and welcome to today's session on the machine learning. My name is Ammar, and I will be guiding you through how data science, especially the machine learning, can be a game changer in our field. Machine learning is no longer the future; it is the present. And in the coming minutes, we will explore how it empowers geoscience and decision makers alike. Okay, so this will be our content today. Some introduction, Python foundations. We will skip some Python libraries because to our tight time. Then we will go through the applications for geoscience. So why Python? Before diving into the machine learning, let's talk about our main goal. In this session, everyone needs to understand the concept of machine learning. I'm not here to teach you the coding. The coding may take around 6 months of courses and sessions. So I need all of you to concentrate on the concept of the machine learning and how you can use it in our field. So why Python? Python is just a language, as C++, Java, scripting, or even CSS, HTML. It's just a language. Everyone is preferring Python because it's fun to use, fun to script, fun to write. It's simple, easy to maintain. It's a glue language, meaning it can connect different systems together without any effort. There is something called OOP, Object-Oriented Programming, which we will not go through it for this session. It needs a lot of time, a lot of effort to make you understand the meaning of OOP. So what exactly is the machine learning? Herbert Simon defined the machine learning as it's any process by which the system improves from experience. So let me choose, for example, Noor Al-Zubi. Can you please open your mic and tell me what is the difference from this picture between the first part and second part?
Okay. Hello, everyone. Can you hear me well?
Yes.
Okay. In my opinion, that's the first picture or the upper one. When we use data and program, just we get the output. And in this case, for this special data, we use the specific program and getting the output as a figure or diagram, and that's it. But in the second photo, if we are using a programming language, so the data and the output from the first time or another, or we can say that the output. Actually, I don't know exactly, but in this time we can use the same code for specific cases, not just one time, for many
Okay.
times.
Okay. Thank you, Noor. Let me explain it for you. We all use a program or software to put on our data, then do some analysis and get an output. For example, we use Petrel to load seismic, doing some interpretations, getting an output which is maps, subsurface depth maps, structure maps, whatever. So this is the first part of the picture. Unlike the machine learning, I am giving a data with an output, training the data on the output I have from other projects, then let the computer do its own calculations to compute the output without any interference from me. That is the difference between the machine learning and the traditional way we are dealing with software. There is no software we are using. You just giving the data some algorithms and it find its directions and give you an output. And the program here means a model, machine learning model, machine learning idea. That idea you can run on any data you have, giving you the output, the exact output which the software is going to give you. So I will explain it by this picture. If I asked all of you, who is the Chinese? Can anyone suggest who is the Chinese in this picture? Anyone? Open your mic and answer. It's okay.
Hello,
Hello, Muhammad. Go ahead.
I think the one in the middle called 𝗟𝗃,
Okay.
also Eddie in the left.
Okay.
Also the one in the right one called Daniel, as I think.
Okay. So I will respond to you. Let's take, for example, Daniel. Yes, it has some Chinese structure in the background, but he does not like a Chinese. Eddie, yes, he looks like a Chinese, like Eastern Asian, but his name is not a Chinese. 𝗟𝗃, okay, it has a Chinese name. Um, maybe she is. This is exactly what the algorithms and your model you have script does with your data. It classified, giving it trends, giving it ideas. Which idea or trend will be applied to the data? Does the name is correct as a Chinese? Does the face? Even the background, the clothes, the same is applied to geoscience. The same idea. By the way, it's 𝗟𝗃, which is the Chinese, by the way. So how the machine learning works? We start with collecting and loading the relevant data. Each data has a priority to your model. So you gather all the data you can gather, then clean it, format it, and handling missing values. Please concentrate on the missing values. Then you apply a machine learning algorithm, train it on the data, test the model, and get you a result at the end. So what is the difference between deep learning and machine learning? Okay. Machine learning works with structured data like seismic attributes, production rates, dogs, whatever. But when you go to the deep learning, it works best with unstructured data like images. Like if you are dealing with core images, dealing with seismic volumes, of course, deep learning will be the best fit. So you need to know which algorithm you are going to use based on your data, based on your data analysis, and will you go through machine learning or you will choose deep learning? So this is just a presentation. I do not like to do some presentations in a machine learning session. I believe in coding and scripting. So let's start scripting. Any questions about this presentation? Any questions? Okay, fair enough.
Sorry, I have a question. I have a short question.
Go ahead.
How about how you can do the intake data? I mean, how do you consider when you have structured data and structured data? How you can classify this data in
Okay.
geologies?
Okay. We will go through that in the application. I will clarify it more. Seismic data is considered to be unstructured data. You have not one trend. Unlike well logs, you have a trend in your logs, and we will practice on the well logs today. I will tell you how the well logs is more structured than seismic data, and you will see some results traditionally using the machine learning, and it's okay. We will show you the difference in the next few codes, okay?
Okay, thank you.
Okay. So we will go through the coding starting with Python. I will give you some hints, some few basics, fundamentals of Python, okay? Everyone learning Python will start with print. Print is a function, is a word in the language used to give you an message, give you an output, to show you the output without interaction. Guys, please, without interaction from you. Just me, as someone who is writing the code, want you to see a message from me. So we use print. So for example, print
Mr. Ammar.
Okay, eh?
Mr. Ammar, I'm sorry for the interruption.
Okay.
So we can see two drawings, blue lines in your
It's not
screen.
mine.
I don't know if you can delete it. I was trying to do it by myself, but like I cannot make it. I think only you can do it.
Let me see. Okay.
Oh, thank you so. Yeah, and there is a
Thank
little black. Yeah, you're good. Thank you so much.
Okay, thank you. So, for example, let's print an hello Noor. One moment, please. Just a moment. I don't want to see that. Okay. Perfect. I hear the double angel. Okay. Okay. Do you see the code line?
Yes, we can see it.
Okay.
Yes.
So it's showing me down there, hello Noor. It's just a message. I can write anything to respond to this message. So when you see at print, you will see these parentheses and okay. So in contradiction with print, you will find a function called input. It is doing that same that print is doing, but with little different over here, which is asking you about an input, a reaction from you. Like, sorry for the background. Hello. Just to give me a moment, please, for the background noise. I'm sorry. Give me a moment.
Take your time, easy, easy.
Oh God. Thank you. Thank you for patience. Print is just showing you a message, showing you an output, but input is showing you the same message and output and asking you for an interaction, asking you for your response to it. So the first one, I cannot write anything, but in the input function, you will find this part is like write something to me. So hello, not using the input function, I can write anything, anything, anything. So this is the difference between print and an input function. Print is showing you the output, input is asking you for your interaction. Okay, so print, you can write text, you can write numbers. You will find here the number. But there is a huge difference in Python between this one and this one. This one is considered a string. The meaning of a string is just a text. You cannot multiply it. You cannot divide it. You cannot give an exponent. This is a text, unlike this one, which is a number. The output is the same over here. But when I type the type of that one and that one, you will find over here, it is giving you that first one is a string, Be careful, because when you are working with a huge amount of numbers and data, just giving you a semicolon over here or a double colon, you will get masked by the numbers and you will get a false data. So the other one is integer, which is a number. So you have two types of numbers, print one, print one. The second one is a float. A float is a number that have decimal fraction. So the integers are a good way to deal with with your data, but when you are going to deal with fractions or floats, you will get a huge amount of calculations and computations, and it need a lot of concentration from you when you are dealing with the data. So you have strings, which is any name you can type. You have numbers, integer, and floats. The last type will be Boolean. Boolean is literally, I am asking you, this is true or false? Everything using computers is just a true or false. Print, true is larger than false. Print, true is lower than false. I'm asking all of you, which is right? True is larger than or smaller than? Anyone? You can type in the chat, by the way, it's okay.
I think larger than.
Of course, and let's see it. It's giving you a true in the true good wakar. In the true condition is a true, and in the true condition, if the true is smaller than false, it will give you a false. So true and false is the main base you are going to deal with the computer science, by the way. So you got strings, numbers, literals we call, and Boolean. Now, this is multiplying in Python. This is dividing in Python. This is dividing in Python. This is dividing in Python. Each one of these has its own function. For example, let's print 1 multiplied by 3. The output would be 3. So exponent, it will be 1. It will be 8. So let's divide 6 by 2. It will give you 3, but this one is a float. This one is a float. Let's divide 6 by 3. This will give you a 2. This will divide 14 divided by 4. Anyone can suggest or answer this question, please? What will be the result? 14 divided by 4. Anyone? Hey guys, anyone?
Will be a float?
3.5, the rest. Okay, the rest. Okay.
Its answer will be 2. That is the remainder of the equation.
Reminder. Perfect. Perfect. This division in Python is just the reminder of the division. You will need it in some points in dealing with logs. You will need this one, this division mark. You will need only the reminder of the division. You do not need the all of the division. You do not need a float or integer. You just need the 2. You will see it in the next few codes. So we got strings, literals, Boolean, let's say priorities or basic operators, multiplying, exponential, multiplication, division, integer division, reminder. We will go through something called variables. Variable is like a box. You are giving it a name and you give it a function. Let's give you an example. A variable called, for example, 𝗟𝗲, and you put an if statement. If that variable called 𝗟𝗲, in this case, print yes. Oh God, yes. The name is right, for example. But if the variable is not equal 𝗟𝗲, is not equal 𝗟𝗲, print no, the name is not 𝗟𝗲. Do you hear the background noise, guys, or?
No, there was no background voice.
Okay, good. Okay. So based on this variable, I'm giving just a box with any name I need and giving it a value. And I have put what? So the if statement here is calling if that variable equals 𝗟𝗲, just to print this statement. And will they give us a certificate for the yes. And if not the variable called 𝗟𝗲, in this case, print no, the name is not 𝗟𝗲. Let's else. Okay. So when we change that 𝗟𝗲 to, for example, muniib, no, the name is not 𝗟𝗲. So we need variables to give us some larger title, larger statements to go through and go with, okay? So let's do something more interaction with the user. So we will do print hello there. This is a machine learning session, and put variable one, which is input. What's your name? If the variable واحد equal, for example, muniib, in this case, print yes, you will get the certificate. Else, print you will not. And so it is now asking me, what's your name? For example, I will write 𝗟𝗲. You will not get the certificate. But if I have written muniib,
You will
get it. And see this trick, muniib. You will not. The same muniib, but this letter is capital and this small. This is a huge issue in Python. Every letter in your word is important. Please be careful. This mark is different from this one. This one is different from this one. Each of these you will, by accident, put in your code and will destroy it. So please be careful while using or coding using Python. So we will go to while loop. I will tell it to you in English and let you explain it to me. While Noor is doing her researches, please say hello. This literally is a while loop. While Noor is a variable called whatever doing researches, while Noor equal to doing researches, print yes. The while loop has a great issue. If the condition is right, it will always run, always, without any break. Let's test it. See, it is will run to the end of the world. It's an infinite loop. You need to break it. But when I break the while loop, it just say yes. So the while is every software in the world is a while loop. Every software. Every software in the whole world is a while loop. I do not want a software when I get it, an input, it stop after it. It breaks after it. No, I need a while loop. So you need to be careful using a while loop. Either you will get a software or either you will produce a virus. Believe it or not, this is a virus. This endless while loop is a virus. Understood? Just write in the chat, guys. Talk to me in the chat. You got the idea of while? Again, I am not explaining the coding of Python. This is not a coding session. Python need at least 3 months of teaching and learning. Basic Python. Good question, Muhammad Gulham. I cannot teach you Python without any basics of Python. I cannot teach you the machine learning without any basics of Python. Let me give you an example. This is a code in Python, okay? And let's stop over here. And I told you this code list for the function we have, this for loop, the file name, called the path of it, printing name, printing last file shape, printing length of the data frame بتاعتي. I cannot teach you that. I need to get you step by step. So you need, yes, to understand the basics of Python. So our friend here in the chat is asking, are we learning basics of Python? Yes, I'm giving you some few basics of Python. I cannot go through these data analysis and machine learning without giving you the basics of Python. Okay, understood? Okay, let's go through for loop. So we have a while loop, which is while we have a condition, do something. You can always do the same something or break. So the for loop is designed to do more complicated task. It can browse large collections of data by item. Let's test it. Let's say our names Ammar, Munib, Noor, Ahmed, for example. So I need to get the names of this list. So full name in that list, print name. So it should print Ammar, Munib, Noor, and Ahmed. Ammar, Munib, Noor, and Ahmed. So the for loop is important function to get into your data and export some parts of it. For example, I need only this one, this one, this one, this one. I will tell you how. Okay. In lists, this is called a list. Okay. عمار 0 1 2 3 4 5. A is considered a zero number starting with a zero. M is 1, M is 2, A is 3, R is 4. In Python, the count starts with 0, guys. 0, not 1. We are not starting with 1. In Python, any counting starting with D0. Okay, this is important, and we will see it in the data analysis right now. Okay. Okay, let's take that. Okay. So there is some called functions. Due to our time, we will skip it. Pandas, we will give you some hints about pandas. Okay. Pandas. No. Sorry, guys. Okay. I don't need that. This okay. Pandas is a library. So what is the meaning of library? A library is someone who has written a code of like 5,000 of code lines, and I am not required or requested to write the same 5,000 of code lines to do the same function or to do the same output. I can import his own script, his own codes. This is called the library. It's just someone who have written the code doing a specific job, and I import his own script. He just written a script, and I have no time to write it again, guys. So this is called a library. We import the library as BD. So we open the pandas library. Just imagine, these are the codes of pandas. I am not going to write the same code again to do the same output. I just import it. So pandas is good in dealing with Excel files. Excel files is in love with pandas. You can do anything you can do in Excel, you can do it with pandas. For example, if this is a data frame, some sort of data frame, Muhammad is 456, Ahmad, Hajj Ahmad, whatever, and these are the index. So I asked him, please print the data frame. Again, they're just a variable, a name. You can call it whatever. So do you see this table? You filed in the Excel file. So pandas is the programming part in the computer dealing as Excel files. objects. You are not opening an Excel file, giving it Muhammad, Ahmed, Haj Ahmed, giving him it the English, math, Arabic. No, just a simple code. Try to use the same table. Understood, guys? For example, this is another data frame. Okay. Let's print this data frame. Population. We will import as BT. So now we have another data frame called country, capital, population, and it has its own inputs. And now I am giving these data, the data frame, the table frame from pandas. Pandas as a library, it can reshape your data into a table in a function called data frame. Data frame needs two things, columns and rows. I'm giving it the columns, the country, capital, population. And from these columns name, it can get the rows. And I told it, put it in a data frame shape, then print it. So the difference is between print data without a data frame and the same data frame, putting in it using pandas is a hugely different. This is without data frame. This line. And this line is while you are using a data frame from pandas. Pandas is a huge benefit while you are using or dealing with tables of and data frames. Okay?
Sorry, I have the question.
Okay, good.
Can
Go ahead.
can a data frame be a data set
Yes, of
or
course.
both?
Whatever
Okay.
you like. It's okay.
So please tell us about a little bit, what is indentation in Python?
Can you write your question in the chat, please?
Sorry, my question or
The second
So my
question.
question, what is indentation in Python programming?
What is that? Can you write down your question in the chat, please?
Yeah, sure.
Okay. Okay. So we got some basics in Python. We understood the meaning of library and how pandas is dealing with any data you have and convert it into a data frame. So we have another library called 𝗟𝗲. 𝗟𝗲 is just a library used to read and write log files, ASCII files, LAS files, whatever. If we have a deep strike data of the rocks, then how can we put and how they run? Okay. This data, you can write it as a CSV file or an Excel file, and you can write it simply using pandas, okay? Uh, Doing the charts, you can get that same idea we are going to do now and do it with the data you have. It's okay. It's okay. General, okay. Just a moment. Give me a moment, please. Okay. So unless you read CVS, pandas can read the CVS file. Pandas, not LSU. We'll go now for LSU. LSU is used to read the LAS files, ASCII files, anything with related to logs. So we need LSU to read the LAS file, and we need the pandas to put the LAS files data into a data frame. Okay. So now we are reading the last file, and just a moment. What's going on?
Did you import the library already, or
What?
did you import the library
Yes,
to read this
yes,
data set?
yes. Let me check the file, please. Verification. Yes, let me check the path. Data,
Sir,
data, apps. We do not have that part. Machine learning session. Data, apps. Good. And this is the shape of the last file. So let me give you some sort. This is the last file, guys. Don't know how to get it the second. This is the original last file we are viewing right now using the Python. That's it. Just imagine you have these data scattered along the last file. Can you do some calculation on it? Of course not. This is a huge scattered data. You cannot deal with your mindset, with your background, with your experience. You cannot deal with this huge amount of data, scattered data. There is no trend you can draw right now between this data. But when you get it in a data frame like that, yes, you can using the machine learning to draw some trends, to predict some structure between this data. So I'm telling it this part, what you call it, what is the type of it? It tells me it's a frame put in a data frame. It's a data frame called of columns, names, and rows. This is the start of data analysis, to put your data into a data frame. You can loop in it. You can go with a for loop to extract some parts of these columns. Just imagine we have 35,000 of rows. Your human mind cannot deal with this huge data set, but computer can. You can run a machine learning algorithm, will go through these data and give you an output. So its shape is 35,000 of columns against 20 columns name. This is 35,000 rows and 20 columns. So I'm telling it, giving me the header of this last file. Again, the last file shape is like that. It's a huge mess. And in our data analysis and data frame, it's shaped like that. So I'm telling it, give me the head, the first 5 columns, first 5 rows, and the tail, the last 5 rows. I just need to see how long the data is. Describe it, giving me the count, the mean, standard deviation, minimum, maximum, 25 quartile, quantile, blah, blah, blah. Just imagine you are running these data analysis in one line, one code line. I'm giving right now the same file. I'm giving you the same file and asking you to give me the maximum and the minimum and the standard deviation. You will never get it in just a code line, in nothing, in 0.0 seconds. This is the power of machine learning and data analysis. So I'm telling it, tell me the column's name in this file. It says dips. These are things I have done it to the last file to make it more complicated. PS, caliber, الROB, الDT, DTS, الGR, gamma ray, الNFI, الBIF, blah blah blah. iLook, okay. So iLook is used to get this is let's say the rows. When I type this mark is called, I need all of the rows of the 10th column. I just need a certain column and its own rows. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It should be gamma ray. We will exclude dips. 0 1 2 3 4 5 6 7 0 1 2 3 4 5 6 7 8 9, and I need the gamma ray column and give me all of it. I want to remove the nan values. I want to remove the nan values. And don't want to list it. Okay, now I want to export or get only gamma ray and DT columns alone from the last file. Only gamma ray against the DT. This is the power of data frames. This is the power of pandas. This is the power of Python. You can manipulate the data. Whatever you need with the data to do with the data, you can do it just with a simple code line. You cannot do that with this huge amount of data. So I exported the gamma ray and the DT, all of the rows of them. Then I inserted certain columns. Now I am manipulating, filtering, cleaning this huge amount of columns. I just need الROB, الDT, الDTS, الgamma ray, الNFI. I just need this particular columns. I do not need all of that. Just imagine a huge amount of data. I do not need it. I inserted these columns to make it more complex to you, by the way. Now I have the last file more appropriate to deal with. This is the basic last file you can deal with. We will not go through the function. It will need a lot of clarification now. Let's go here. Okay. البير plot This is called a pair plot. Now I have cleaned the data, as you have seen. Now I need to know the relation between each column and the other column. For example, the DT against 𝗓. It shows me that when the when the DT increases, the 𝗓 increases, and this is consistent. This is right. But when I go to a relation between gamma ray with DT, I find some scattered data over here. Do you see it? I don't like that. This data maybe a miss, maybe spikes. Maybe I didn't clean the data right. This data sitting away from the general trend. This part. When I see the gamma ray with the 𝗓, I find some scattered data over here. When I ask you to write a trend in this part, most of you will say, let's draw, annotate. Most of you will say like that. The others will say, no, you neglected these points. It should be like that. Come on, these could be neglected too, and it could be like that. Just imagine we have put 3 different trends. Will it change the algorithm you are going to use? These scattered data you need to clean using the data analysis. This not reasonable data, this part. You need to do data analysis, and data analysis, how you do it? With using data frames, and you using data frames by using pandas, and pandas you need to read the last file. Reading the last file, you need LASSO. It just steps. You write simple Python codes. Then you go to the library to read your text files or whatever. Then you convert it into data frame. Then you put a relations between your data and each other. You see the consistency of your data. Once you finish, you start to clean the data, format it, play with it. The best thing about data analysis that you are playing with the data. You are inside, deeply inside of the data. Unlike that any other software, you are giving him the data, it's giving you an output. Come on. What if the data is corrupted? Your output shall be corrupted. So you need to understand data analysis. This will make you different from the others. This what will make you different from the others. Manipulation with the data is the most important thing. Old school guys will get the seismic cube uploaded on Betrel or TNAV or OpenDetect, whatever, and start doing the interpretation. What if the cube geometry wasn't right? What if? The machine learning can tell you that the geometry is not right. There is something corrupted with your cube. So you need to understand data analysis and its job. Why? Why should I learn the machine learning? I will answer you easily. See this. Just one moment. This is my own code. I have written it. Doing the machine learning from scratch. From scratch. I have written around 1,200 code lines. Let's test it. Just a moment. This is a tool I have made from scratch. I can load a last file, CSV, view it, manipulate it, and do some predictions. Just let's take data apps. For example, this part. It asking me for the depth column. It will be MD. I want to plot the time integrate derivative and instant frequency in the envelope and prosody. I can do whatever I need with the curves. Whatever I need. I will answer your questions after this part particularly, please. Please concentrate here. So I do not have a prosody curve, and I need to predict the prosody. Just imagine you do not have a prosody curve and you want to predict it based on the data you have. Let's do it. Sorry for the small font. It's just a bug I need to fix with the code. I wanted to predict prosody. I will give it the time. I don't need time. I will give it in. I'm the one who created this tool, this application. Just doing whatever you need. This is the data I will give. I want you to see this part. Here, the answer of this picture. I have the data. Integrate, derivative, and instant frequency, envelope. And I will train it on an output, then get the model. Let's do it. I wanted to predict prosody. Well, based on integrate, derivative, and instant frequency, and the envelope. We have not a prosody for now. So I will choose decision tree, or linear regression, or random forest, or support vector machine, whatever. I will, for example, choose random forest. And it drawing to me the forest it has relied on to predict the prosody. It's telling me that the mean squared error is 0. I will explain the 0 meaning and 0.96 R2 score meaning also. So it's asking me now to plot the prosody, which I have already I had, and the predicted prosody from random forest. Let's see how the data will be matched. Just imagine. This is an output. The output of prediction. The blue line is the prosody I had. The yellow line is the predicted prosody. Just imagine. Just imagine. I can predict the data. Okay, Aniket, it's okay. So I just predicted the data from nothing. It's literally like the actual data. And here you have a spike. These spikes maybe could be corrupted issues or parts in the last file. It's okay. Why not? We have also these spikes is recorded. So guys, you need to understand the machine learning is not just a code, it's a concept. I have taught the machine learning once in an oil gas and company in Egypt, and the reservoir engineering general manager asked me, why should I? Why should I learn the machine learning? I asked him, have you ever faced an issue or a problem that the software couldn't help you with? He said, yes. I told him, so what? Create an idea, an algorithm, a code that can help you then when you face the same issue. Guys, I'm not here to give you coding session. This 1.5 hours. And I cannot teach you Python, machine learning, data analysis in 1.5 hours. I'm giving you a concept. I am not telling you when you finish this session, you understood everything I have told you. No, you just have got the concept. Machine learning is used to predict the data based on the data you have. It's giving you trends. When you analyze the data you have, like time, integrity, derivative, and instant frequency, envelope, you can easily predict the porosity from them. You can predict anything. But when you analyze your data, format it, clean it, give it the shape, you prepare it for the prediction. Just imagine this instant frequency, for example, is somehow corrupted. Of course, the output will corrupt it. Can this prediction be misleading because I have used RockDoc to predictive curves and some are misleading? Okay, can these predictions be misleading or not? Let's test it. Let's test it. We will do the same porosity. We will take integrate derivative instant envelope. We will take random forest. I will tell you how to quality control your prediction. I need, for example, let's see who are the participants. I need Sam. Are you with us, Sam? Sam, do you hear me? Sam is not here. Michael. Do you hear me, Michael? Okay. Muhammad Al-Aqar. Muhammad. Are you with us, Muhammad? Okay. Anyone listen to me, guys? You can open your mic and answer me. It's okay.
Yes, we can hear you loud and clear.
Okay.
Yeah, we can hear.
Okay.
Yeah, we can hear you, sir.
Okay, Michael.
Yes, your sound is clear.
Okay, good. Just a moment, please. Okay, Michael. When I show you mean squared error is 0 and R2 score is 0.96, can you explain it? I do not tell you to give me the right answer. Just what do you see? Michael Odini? Michael? Humberto? Leonardo Ramirez in one and okay, Humberto. What do you
Yeah,
see? What do you see over here, Humberto? Just give me a thinking. I don't tell you. Give me the right answer. Just what do you see in this box?
okay, let me
Give me a
think.
guess. Give me a guess.
That does mean an error of prediction. I mean that does it not cover the mean of the maybe of the
I think there is no error in the prediction.
Is that good to have not an error in our prediction?
No, errors always exist.
Oh God. Wonderful, Muhammad. Wonderful.
Thanks.
Guys, mean squared error means the average, it measures the average magnitude of the prediction error. How many errors in your prediction? How far the model predictions are from the actual value? There is nothing perfect like that. This is called overfitting. I am fitting the actual output, giving it an overestimation. I do not need that overfitting. When you find a mean squared error 0, come on, you are in a huge issue. So can these predictions be misleading, Fawad, Nasser? Yes, it can. But this is why we use mean squared error. We wanted to know how our model is deviated from the real model, how it's far from the actual values. We should see some errors here, and I will tell you, I will show you some errors. So R2 square is high. When you find the R2 square around 1, it's generally perfectly fitting, and we do not need that. We do not need that. If you find a 0, the model that's mean model does not better than predicting the mean. It's just predicting the mean. Nothing more, nothing less. It doesn't work.
What could be the value other than 0?
It could be 0 up to 1.
Uh-huh.
1 means you are very far from the actual data. 0 means you are really, how to say it, fitting, very, very fitting for the prediction data is fitting, overfitting with the actual values. Let me show you how. Here, you will find the two curves literally on each other. Literally on each other. This is overfitting. We do not like that. I will give you an example. Very good example for you. One moment. Over here. This prediction, I have used linear regression, support vector machine, decision tree, random forest, okay? I want all of you to see this blue line. Blue line. It's just a line. It doesn't take these curves. Is this a prediction I am going to drill a well based on? Of course not. Just imagine
Because there are no errors.
No, there is a huge error. Just imagine the prosthetic curve. Is the prosthetic curve a line? Of course not.
Yeah, it's never a line. Yeah.
It's a curve. Literally, the red line or red curve is the porosity. Just I'm giving you, I want to say the annotation. Give me this here. This lines curves is a porosity. The original porosity is the actual data. Just imagine I'm giving you a trend. There is a huge error. I cannot depend on the porosity in this area. Just imagine the porosity here, let's say 0.3.
0.3.
The actual data is telling me the porosity is 0.6. Just for example, this is a huge error. Sometimes when I come in this area, this is a spikes. Spikes mean an error. An error we didn't clean when we are dealing with the data frame. The original data should be like that. Doesn't exceed this line. Doesn't exceed this line. So this part is spikes. So to you have two options. If you used a random forest is a true or false questions. I will give you an example. True or false questions mean تعال predict
Could you please
porosity.
read the red lines shown on the
Just
screen?
one moment, please.
Thanks.
Let's predict with linear regression. Just R2 scoring is literally telling you, get out of here. Do not follow this this algorithm. I wanna to plot the original porosity I have against the linear regression porosity. Just imagine this line against these curves. This is a huge error. Linear regression is not used for a multi-dimensional data, a curves. Linear regression is the best if you are dealing with dots. How? What that mean? Okay, annotate. Let's imagine this is some data we have, okay, and the other data is like that. And I told any one of you, draw me a line that separates these two sets of data. He will say like that.
In the middle.
He will draw it like that, right?
Yeah.
So linear regression is used to separate two different data sets are originally separated. But when I deal with some data like this is part of data, and the other part of data is like that. Until you right now, draw me a line separating this data. Will it be like that?
No.
Will it be like that? Will it be like that? Will it be like that? Here comes the error. So choosing the algorithm based on your data is based on the understanding and consistency of your data. Please, guys, data analysis is the most important part of the machine learning. You cannot skip machine learning. You cannot skip data analysis to go to machine learning. I'm not. I wasn't willing to give you codes teach you programming, giving you scripts. No, guys, I was today tending to give you the concept of machine learning. Why we use machine learning? Why we need machine learning? I'm not today coming to teach you the machine learning. Machine learning needs at least 15 days, 7 or 8 hours per day to teach you. The last course I have taught it was 25 days, 8 hours per day to teach the machine learning. I don't want all of you to come get out of this session telling me we understand the machine learning. No, you don't. Just to get the concept of the machine learning, how we can exploit it in our industry. I am using it in seismic. I am using it in production data. I'm using it to predict the kicking while I am drilling. I am using it in petrophysical evaluation. I am using it in autocorrelation. I am using it in everywhere. It's just an idea you need the computer to work on. That's it. That's it, guys. Have you got the concept of the machine learning and how we can use it? I cannot teach you the machine learning in 1.5 an hour. There is no one can do it. I just wanted to give you the concept of the machine learning. The concept of the machine learning. Have you got the concept, guys? It's okay, open your
Yeah,
mics.
definitely.
So this is a tool I have done it. It do everything I need for petrophysical evaluation particularly. I import the data shape, it's like an Excel file. I do whatever I need. I plot these curves. I predict any curve I need. I do a lithology prediction. I do whatever I need. That's just a tool, I use it. I use another tool called correlation. Just imagine you are going to drill a production, an exploration well, and your manager asking you where the tops will be. Just imagine. You need to give a proposal to your manager to tell him where the tops will be when the mudlogger or the driller face it. Just imagine you train a model based on the logs in your field and you can predict it. This is what I have done. I predicted the logs, the tops. Why not? I want to show you something. And I show you something. Evo analysis, fishes prediction. ثانية. One moment, please. Seismic petrophysics. Oil shale, brine, no. I wanna show you something before we finish this session. No. Sorry, I have a lot of codes. Please, guys, when you write code, please put in somewhere you know. This is a prediction of fishes. Okay. I can see it. Autocorrelation. What is the correlation? I wanted to show you the correlation model I have done or I have written, which is a huge model. I have run it along 1000 of wells, and it could predict any tops. The only shifting is around 30 feet shift, which is allowed, by the way, by our managers to have shifts up to 30 feet. So the model was running actually perfectly. Plotting glass. Sorry guys, I didn't find the pandas. I believe it is that. Shit. Maybe maybe I will share with you the correlation model. We will stop here, guys. Any questions? Do you have any question to ask? Go ahead, guys. To avoid overfitting in a machine learning model, you should focus on improving its generalization by using techniques such as increasing the... Okay, wonderful. And when penalties drop out. Right, Leonardo. But session is for beginners or starters. I cannot talk to them like that. I need to be simple. I need to be somehow clear with everyone. So thank you for your comment. I appreciate it. And yes, you are right, but you also can minimize the complexity of the algorithm you are using. For example, uh, the random forest. Random forest, it's like you are asking, a main question. Yes or no? If no happened, yes or no? Another question. If no happened, another question. Yes or no? Blah blah blah. So you can cut the decision tree, the random forest here, decreasing the complexity of the trees. Any leaf you can cut, it can decrease the complexity, decreasing the overfitting. So it's based on your data and based on your algorithm you are using. So I'm done, guys. I'm finished. Did you have any questions? Any questions?
Many thanks.
Thank you. Anyone has any question? Again, maybe you do not understand 100% of the session. It's okay. I am not teaching you the course. I'm giving you a hint.
Okay, Mara, I have the question, but just machine learning give more approach to predict some special some that, for example, Petrel or some software like give the tools to no that some software that use some companies in this case.
I didn't get your question right, but I will tell you something.
Okay, I will repeat again.
Okay,
So
okay.
machine learning give more approach to predict some special zone, for example, in hydrocarbons or some relevant field than Petrel or some software that you know
Of course,
in the
yes. Of course, yes. I have worked
okay.
with a company to build a model to tell us where we should drill the next well. The Betrayal or other software telling to drill in a dry well based on the machine learning. The machine learning telling us do not drill over here. This was a huge project to me to tell the company where to drill using only the machine learning. Yes, Betrayal is giving you the subsurface structure, blah, blah, blah. Everything is looking good, but it cannot help you to choose where to drill. It's based on you. And when it comes to use, you are dealing with a huge amount of data. You cannot deal with it. You cannot process all of the data you have. You should get some misleading by some sort of data you see it, So the machine learning told us to not drill a specific well, and the company didn't follow the machine learning, and it was a dry well, and it was a disaster. And now maybe they will declare that they are broke. They are getting broke due to that dry well. The machine learning telling you drill over here and do not drill over there. And you still go to drill over there. So they got crashed, literally crashed. So yes, machine learning can tell you something that Betrayal cannot. Yes, the machine learning can give you the idea to get inside the data, to flow inside the data, to do your data analysis, unlike the software. Understood?
Yes. Okay. Thank you for your answer. Thank you.
Thank you. Any questions?
Could you please elaborate more on the future of machine learning in oil and gas industry? I mean, explaining the.
Okay. I had the last two huge projects I have done. One to predict the production forecasting for a company considered to be the largest oil and gas company in Egypt. It was a huge project, really needed the machine learning. We had around 15 million cells of Excel file, 15 million. And we need to do data analysis on that Excel file. Just imagine Excel file, Excel itself cannot do the data analysis on the same file. Just imagine Excel cannot do data analysis on its own file. I have written a Python code, done my data analysis, run a model, predict how their productivity will be in the next 10 years, then how their production will be in the next, after 30 years from now. The machine learning is going to be the new software of the market. The new software. There will be no uses of the software. Software, yes, we got the best of the software, but it is not the trend. It is not the future. We're done of the software. We are done of the limits of the software. Each software has its own limits. So machine learning is getting you out of that loop, out of that circle of, I have a limits as a software, so you have a limits as a human being. Machine learning is getting you out of that.
So we should invest in learning machine learning.
Of course, 100%.
I totally agree with you, Ammar, because actually I had a lot of challenges when I did my PhD, that many software get stuck with a huge amount of data. But I have just one point, if you give me a permission.
Go ahead.
Actually, I expected to see that one real case study, how you deal with this case study in geoscience. where is the challenges, where did you struggle, and how you fix or solve the problem in while you wrote the code. I really appreciate your time and your explanation today, and you remind us with some basic which is necessary. But maybe in near future, could you please provide us with a new session that you show us at least short case study? What is the challenges? What is the main struggling point? How can we deal with them? If you have time, thank you.
Okay, let me explain.
Yeah, I agree with her.
We will call it an X company for data secrets. We will call it an X, okay? They had the last chance to drill their well, and they were terrified to get another dry well. They drilled 3 wells, got them dry. So our Egyptian Egyptian corporation gave them the last warning. You will drill the last well. If it got dry again, you will get fired from the market, Egyptian market. I have talked to them before coding or scripting or even training the model in their field. They were terrified. They cannot handle the data. There are a huge amount of data, but they need to drill. They are afraid of getting kicked out or got a blowout. They have the production of the field which is declining. They have a lot of issues. The machine learning can deal of all of that in just a blink, just a moment. The task that need from you at least a week or two, machine learning can do it in just an hour or a minute. And it's more convenient than you because it's dealing with numbers. It is flowing inside the data. Isn't low? Okay. So when I have talked to them, hey Ammar, help us please. We need a machine learning model to predict where we are going to drill the next well, the next last well. I told them it's okay. I will help you. Give me your data. Give me your protection data, subsurface data, seismic data, logging data. Give me everything you have. These whole of work can take a huge team, a huge amount of people, a huge amount of time and effort. Machine learning does not need all of that. It just needs a supervisor. You supervise it. So the time was an issue. Their budget was an issue. Their experience was an issue with the field. So they had a lot of issues. I have run the model, told them the model is telling us based on the model itself it built, it telling me to drill over there, guys. The porosity is perfect. The permeability is perfect. Everything is right. Everything is right. Go there. They refused. They got a dry well and blah. They got broke right now. And maybe they will get out of the Egyptian market. So machine learning is useful and I have faced it. I have seen it. So for the next question, what can you tell those of us that want to go into machine learning and deep learning if we already had domain knowledge? Okay, what is the roadmap to learn and how long can it take? I will start with the end of your question. How long can it take? It can take your whole life, my dear. Can take your whole life. uh, learning has no time. You always will learn. There always will be new algorithms. You need to always learn. So, and so how do we load the ls files? Okay. So for Python and the math basics, you may take up to 2 months. 2 months are good. So for the machine learning foundations, you will take around 2 months basics foundation. That's the foundation. Then you go through deep learning. You go for 4 months. 4 months based on your capacity. Of course, your capacity is the major element over here. Then real world machine learning, deep learning with domain data بقى والشغل ده and domain data, it will be like forever. So if you are talking about the basics, you will take around 10 weeks for the basics. After the basics, you will learn forever. So my advice to all of you, do not start with geoscience in machine learning. Understand Python itself. Understand machine learning itself. Understand deep learning itself. Then start to employ them in the geoscience. Do not start doing that based on geoscience. You will never learn. I kept studying that around 7 years. 7 years. 7 years. 7 years I'm studying machine learning, Python, algorithms, what is the new in the market, and I may take the whole life to learn the machine learning, but just you should start. Big is asking how do we load the ls file? To load the digital log. Do you mean a digital log الانترشينج ستاندرد or what? Big. Do you mean الواير log data in oil and gas? If you are meaning الواير log data in oil and gas, so you need a library called DLSU log data. DLSU digital log information standard, DS الواير log data. This library called DLSU used it to interpret it or read it. LSU is for last file, ask file. Can we load the feature interpreted on seismic data like faults, horizons, in industrial software along with seismic data and Python to do subsurface modeling? Of course you can. Of course you can. 100% you can, Mutib. The integration between the software and the data you are getting from Python, the integration is usually okay. Any other
I have a
questions?
question. Yeah.
Go ahead, Muhammad.
Will be there in the future webinars that teach these things?
I believe yes. Mega Plus should announce that.
I hope so. I hope so.
But the issue is, Muhammad, I concentrated to deliver to you the concept of the machine learning, not the coding, guys. I'm not here to teach you a coding in 1.5 hour. It's impossible. But if you got the coding, if you got the concept of the machine learning, wonderful. You got the point. Any other question, guys?
Okay, thank you so much. Thank you so much, Mr. Amar, for your presentation. Thank you all for attending today's webinar. It was a pleasure having you with us. And again, Mr. Amar, thank you so much for sharing your
Thank you.
expertise and hosting this wonderful webinar. If you couldn't join us live, the recording will be available soon, and we'll share the link shortly. We truly appreciate your participation and look forward to seeing you in future sessions. Also, as you can see in the chat section, you can see the link in case you want to have your certificate. You can go to the link and fill out the form. We will be having next sessions, next webinars, and we'll be sharing that information with you very soon. Thank you so much and have a good day.
Thank you, guys. Wish you all the best. Thank you. Keep in touch.